What's up, guys? Welcome back to the channel. This is going to be part 2 of the LT230 overhaul. I've spared you guys the daunting task of cleaning every single individual part out of this transfer case. So I'm going to go through and show you what I did, my procedure for that, but I'm not going to show you me actually doing it because it is mindlessly boring. Okay, here's all the parts sorted, cleaned, ready for inspection, and then for basically to start assembling. Each one of these totes represents kind of one step in the process. Intermediate gears, input gear, here's all the center differential parts, here's all your high range and low range gear and your selector shaft, here's your differential housing, here's your rear input shaft, or I'm sorry, rear output shaft, and then the case, and then over here is the front output housing. So everything's been cleaned and degreased. Alright guys, so here's kind of the selection of tools that I use to clean all these parts. So I use this Blaster brand parts washer solvent. I believe it's like a mineral spirits based solvent. Brake parts cleaner. Lots of blue rags. Big pan and an assortment of brushes. So you see here I got, this was one of the primary ones I used, like a, I don't know, a detailing brush. Use that for kind of just breaking everything loose, main scrubbing. And then I used this plastic brush quite a bit for getting down into the crevices and stuff. And then I used stainless steel brushes on surfaces that aren't like super critical, so no like gasket mating surface or anything, but just scrubbing down inside spots where I had some real heavy crud. And then these brass bristle brushes are the ones that I use on surfaces like this, which is a sealing surface, because you don't want to grind on this with something that's harder than aluminum, like a stainless steel brush. You want to use something like a brass brush. Okay, basically all the parts were dirty, covered in grease and grime and everything. They'd go into this little drip pan. I'd cover them with some of this parts washer solvent, scrub them off real good. Then I'd take them outside, spray them down with some brake parts cleaner, then I'd bring them in here and blow them off with the air hose. So I chased all the threads and all the bolt holes on all the parts. So everything that had bolt holes, like here where the center diff lock mechanism goes, on the cover here, all those bolt holes got chased and blown out with compressed air. And then once all the parts were clean, if they needed to get bagged up, they got bagged up, but everything got soaked with a good liberal coating of WD-40. Now I have all the parts in their own little boxes here, so now I can go through, throw the covers on them. That'll keep any dust and debris from getting on them. And then each one of these boxes kind of represents one step in putting all this stuff back together. So that's where we're at right now. This is the long, boring, tedious part, and it's now done. So now we can move forward and start putting all this stuff back together. All right, so we're going to start reassembly here. We got our diff carriers. We got all of our new parts. We have a couple things that we're going to replace, a couple things we're going to upgrade. The first thing we're going to be replacing are these thrust washers. You can see the thickness of these. The original ones were worn literally paper thin, like almost nothing left. So you can definitely tell that is a wear item. This saves the wear on the inside of the diff carriers. So those are really important to change out. We're replacing, these are the old thrust washers that go underneath your sun gears. Ashcroft does send 2 in the mass rebuild kit, but what we're going to do is we're going to put a measurement on these to make sure they're the right thickness. They look to be the right one, but just in case they're not, I have a selection here from Ashcroft that will make sure that we set it up as close to the factory as we can. And we have the new diff carrier nut. This is the one that was staked that we took off, so we'll be replacing that. We got our new high range gear bushing that we're going to be installing, our new HD cross pin, and then the new sun and planetary gears. So we'll start putting this together. One thing you do want to note, guys, you want to try to do this as clean as possible. My shop is probably not the cleanest place to be doing this kind of thing, but I'm taking extra precautions. I got blue paper towels laid down. I'll be wiping everything down, trying to keep everything in its packages until I absolutely need to take it out. Just make sure that you're doing this just as clean as possible. Last thing you want to do is get a piece of dirt or something down in there inside of a bearing or inside of a surface where you're going to have wear, and you know you can end up chewing up a bearing or chewing up a part that you just went through this whole effort of replacing everything. I want to make sure you do your best to try to keep this just as clean as possible. So lots of blue paper towels and just try to work as clean as possible. All right, so put a little bit of lube in there, put the thrust washer on here, got it good and lubed. Set the sun gear down inside the diff carrier, give it a couple turns, work the lube into it. We'll take our new HD cross pin, Give it a quick wipe down. Make sure it's good. So these are your voids for oil to get onto the gear. Just put a little bit of oil here on the cross pin. Go ahead and put our sun gears, our planetary gears on there. Put a little bit of oil on the back of each gear. Go ahead and install our thrust washers. Go ahead and set this in place. Try to get a little bit of lube down behind those thrust washers. Remember from the disassembly how much play we had in there. Well, now there's almost no play at all, so that feels really good. I'll just kind of check it for operation, make sure it feels good and smooth. I'll take our other sun gear, give it a little wipe down, set it in place. Yeah, that feels great. There's no slack in that whatsoever, so that feels real good. Checking for any sort of binding or anything. Don't need to over lubricate this, but definitely want to make sure that all the parts do have a little bit of lubrication on them. That feels good. We're going to match up our marks. I don't know if I mentioned this in the first video or not. You can see right here we got a number 5 stamped into this diff carrier. And we also have a number 5 stamped into this diff carrier. We need to make sure that those line up. This is made as one piece. The bolt holes won't line up if you don't line these marks up, and that's critically important. We'll go ahead and take our other 115 thrust washer. Add some lube. Set that in place. Add a little more lube at the top of it. Again, gave this a good wipe down. Set that in place. Turn this whole thing over. Go ahead and we're going to drop our input shaft in there. Make sure it turns. Make sure there's no hanging up or anything in there. Everything feels good. We'll leave this right here for right now, and we'll just keep checking it as we install all the bolts. Put a little dab of lube on each one of the bolts. Just gonna finger tighten all these real quick. Again, check for function. So the next step is going to be torque these bolts up. So we're going to do it in 2 stages. We're going to do 30 foot-pounds to start with, and then we'll go to the final torque of 44 foot-pounds. So we're referencing our LT230 manual. So here's our final torque is 44 foot-pounds or 60 newton meters. We've already gone through and inspected our low range gear. We've gone through and looked at all the teeth. We looked at all the wear surfaces. You can tell which side was the drive side and which side wasn't. The vehicle had been in low range a little bit, but not a whole lot. We've looked at for wear inside the gear. We looked at the dog teeth here on the outside of the gear. It all appears to be good. We've lubricated all the surfaces for this to slip onto. We slip that on the shaft. Remember, this gear doesn't ride on a bearing or a bushing. It rides directly on the shaft. So we've checked for any sort of excessive play here. It's all in really good shape. The next thing you do is we're going to install the selector Now if you look at this gear, I've already oiled it, so it's kind of hard to see, but you definitely tell one side has wear, one side does not. This is the side that lived in high range. So when we reinstall this, we're going to install it backwards from how it came apart. That way we're putting the worn side onto the low range, and we're putting the unworn side onto the high range. And what that does is that gives us just a little bit extra, this isn't worn at all. So when we put the high range gear on here, this will ride in high range most of its life, right? So now we're using that unworn side of the gear to ride on high range. So just make sure that this is seated all the way down. Make sure your selector moves good, which it does. So we're gonna go ahead and we're gonna oil this high range bushing fairly good. Get our high range gear out. Obviously this is the gear in the transfer case that takes the most amount of wear, because it is the gear that the vehicle lives in most of its life. But looking at the gear teeth, they are in really good condition. They have some wear, but it's very even. There's nothing here that seems excessive or anything here that seems out of spec. There's no chips, no cracks, no real bad worn spots. So it is in good shape. So that's good that this transfer case is in good condition and doesn't really require anything extra. So next thing we'll do is we'll lube the inside of the gear. We'll install the bushing. So this bushing's got to fit right down in there just right. It actually just got hung up on me, but the flange of that bushing points up, dog teeth point down. This will now slip over the shaft, and that feels absolutely perfect. There's no play, it's not tight, feels really good. Move our selector, engages into the high range real good. Engage in the low range good. Moves nice and free. Alright, so the next thing is going to be installing the bearings. You have two different bearings on the center diff. The smaller bearing goes here on the high range side. The larger bearing goes down there on the other side. So we'll give this a quick wipe down. See how that sets down on there just like that. So the old high range bushing makes for a perfect press to tap this bearing onto place. So that's what we're going to do now. All right, I need to back up a little bit. So put this all together, and the high range gear was way too tight. So I already pressed the bearing on, all that stuff. So I went over to my buddy's shop and we did a little bit of digging. Like I had said earlier in the video, I had flipped the high range, low range selecting hub to move the wear from the high range side to the low range side. Well, on this gear, I'm sorry I didn't get pictures of it, but there's a little recess cut on the one side. So when I put it together, it was out of tolerance and it was too tight. I did this on mine with no issue. It was an 03, and that hub flipped, and when everything was in spec, everything was perfect. This one did not work, so I cannot recommend doing that. Just put it back the way it is, and if there's too much wear on that hub, just go ahead and replace it. But everything's working like it's supposed to. Low range gear, high range gear is spinning perfect. Low range gear is spinning perfect. So everything's like it's supposed to be. The next step will be installing a new bearing lock nut. So it has a flat, thicker side and a thin, taller side. The thin, taller side, it goes up because that's the part that you stake. This is where we'll use our special tool again that we made. So we'll get this in the vise and we'll get torqued to spec. So again, we're going to reference the Land Rover service manual here, and this is going to get torqued up to 53 foot-pounds. Alright, so next thing we're going to do is we're going to stake this nut. All right, so I forgot to turn the camera on to do this, but like a knucklehead, I took this bearing and I put it in the oven. I'll throw in a picture at 350 degrees, just until the oven got preheated. And I came out here and I set this bearing on the shaft, and it literally just fell into place. Didn't have to drive it on anything. It literally just set in place. And now that it's on there just like it would. So through thermal expansion, it grew just a couple thousandths of an inch because of the heat. You can literally just drop it right on there. So that's the trick to getting that bearing seated. Another little thing to note here, I did not reinstall this ring that gets installed between the two diff housings. That's basically there as a retaining clip to keep the cross pins in place. With the Ashcroft HD cross pin, those aren't floating pins. They have nowhere to go and they can't move. So that is not necessary to reinstall. So if you are not using an HD cross pin, you do have to reinstall that when you put the diff housing back together. Alright, so the next step, now that we got the center differential all put back together, is we're going to reassemble the rear output housing. This will get assembled and then installed on the transfer case, and that way we can start working on the differential bearing preload setup. Alright, so I just pulled this out of the oven. So we can get this bearing down in here. Alright, go ahead and we're going to install the snap ring down in there. What I like to do is give that snap ring a little tap to make sure it's fully seated. There we go. Snap ring's installed. So the next thing you're going to do, we're going to install the output shaft into the housing. It's still a little warm from being in the oven. That's alright. I have this socket that's pretty close to the inside diameter of the bearing race. I'll go ahead and set that on there. That way I'm hammering against the bearing race, not the bearing. You hear that sleeve moving around here. We're trying to take the slack up out of that sleeve. Sounds like it bottomed out. Now we're slacking that sleeve. Alright guys, so next step is we need to drive this race out of the case. One thing to note here is that this race is recessed below the mounting surface here. So one thing to note here on this rear output housing, you see how this stands off right here? That's actually going to push that race down into place. But if you read the service manual, it says to install this race 1 millimeter below this mounting surface. So that's what we're going to do. Alright guys, so I jumped ahead a step or two and I forgot to turn the camera on, and I'm really sorry, but I'm going to do my best to explain it right now. So we drove the race out of the inside of the case. This is the differential bearing race. Got the new bearing race installed. The next thing I did is I went ahead and I installed the rear output housing. I chased all the threads in the case when we were cleaning it, so then I took and ran all the bolts through a die just to clean all the old Loctite off the threads. We installed the rear output housing, put a little bit of thread locker on each one, sealed it with RTV. You want to make sure that you have the bolts in the right spot. This bolt right here is a little bit longer than the rest, so the important part about that is that when you're done, the bolts should be flush with the inside of the case. If you get one that's sticking in too far, it will hit the gears. So you got to make sure you put those bolts back in their original order. So this is the race that the differential carrier rides on. So this is the old one. We're going to drive this one out. Behind that is the shim. We're going to keep that shim. This distance here in and out is what sets the bearing preload. So we'll go ahead and install the new race with the old shim, and we will temporarily install the front output housing, and then we'll start measuring for bearing preload. Here is the bearing race. This we won't reuse, but here is the factory shim. So we're going to take our original shim, we're going to set it down into place, and then we're going to take our new bearing race and we're going to tap it down into place. I found the best way to do is to take the original bearing race and set it in there and kind of use it to get the new one started. So there's the new bearing race installed in the housing with the original shim underneath it. And we'll put a little bit of oil in the bearing. Get it worked in good. Everything one quick last little wipe down, make sure we don't have any dust or grime in there. Okay. Take the front output housing, one quick more little wipe down to make sure it's all good to go, nice and clean. Mating surface on the front, make sure there's nothing on it, make sure it's good and clean. And then we'll go ahead and set the front output housing in here. Okay. Something I've been doing to all the bolts is I've just been running them through a M8 by 1.25 die. This helps get the old Loctite and stuff off the threads. Make sure the threads are good and clean. And make sure they're ready to go. So after I took the bolts and ran them through the die, I took a wire brush and just cleaned the threads, make sure they're good, clean the heads of the bolts, make sure they're good. So I did that with all of them. So we're going to go ahead and we're going to install probably 4 bolts in the housing. Okay. See how nice those go in now that the threads are clean on them. Alright, now that we got the diff and everything in there bolted in, everything's rolling nice and smooth, right? Alright, now to see if it has an infloat, we're just going to take a pry bar here and we're going to place it between the gears and we're going to see if we have any movement, if we have any lift in the gears, which I don't feel any. Yeah, so that tells me that that factory shim is going to be too tight. So what we're going to do is we're going to pull the front output housing off again, drive the bearing race out. We'll put the thickest shim that we got from the Ashcroft kit, we'll put it in there and see if we get any end float then. And then we can measure the end float and add shims till we get to the right preload. Okay. Alright, so here's that factory shim. Let's zero the caliper out. Came in at 251. So we'll go into our Ashcroft center diff shim kit and we'll pull out our thickest one that they send in the kit. And it's 1.87, 1.86, 1.85. Okay. So we'll go ahead and we'll install this one with the new race and see if we get any end float. I'll tell you, it feels significantly freer. It's in there spinning super easy. Alright, so what we're looking for is movement. So we should have some sort of movement here on the end of that shaft. So watch that shaft, that little bit of movement. That is our end float, okay? So that is what we're going to measure, and then we're going to add thickness of shims to get to where we need to put the right amount of preload on this bearing. Alright, so we need to get our dial indicator touching the center diff so we can get a reading on how much the differential is moving up and down. But this won't reach down in there. So what we're going to do is we're going to take our front output shaft and we're going to set it down inside the diff. Now, when the differential moves up and down and in and out, you can see that. Now we have something to set our dial indicator on so we can get a measurement on how much it's moving. Alright, so next thing we're going to do is we're going to go ahead and we're going to zero out our dial indicator. And now we're going to measure the amount of end float that we have. Alright guys, so you saw that we had 20 thousandths of end float. Convert that to metric, that's 0.058 millimeters. So take your 0.058 millimeters and add our 0.05 millimeters of bearing preload, gives us a total of 0.558 millimeters. Is what we need to make up in our shim. Okay, so convert 0.558 millimeters back to inches, and you get 0.0219 or 219/10,000ths, or basically 22 thousandths. Okay, so went through and measured all these shims, put their measurements on them. Got these two right here. We're going to take our micrometer. All right, and see right here we are at 21.4, so 214 thousandths. That's within 5/10,000ths of an inch. That is going to be our shims right there. That's good enough for me. They don't send shims in small enough increments to make up for 10,000ths of an inch, you know, to make up for 4/10,000ths of an inch. So as far as I'm concerned, that's right on the money. So we'll check again right here in a different spot. Again, 214. So that's as close as I'm going to be able to get with the shims that Ashcroft sent us. So these are our two shims that we need to install into the front output housing, and we'll have our diff preload set. So we'll go ahead and we'll take the front output housing off one more time. We'll go ahead and we'll add our two new shims in there. I'm going to put the thinnest shim in the middle, the thickest shim towards the back that you would hammer on if you had to drive it back out again. I'll set those down in place. Now in theory, you could just bolt this together with your sealant and everything, because we did all the math and we did it right. But just for fun, we're going to put it together one more time, and we're just going to verify that everything feels right. Feels really good. Spinning nice and free. Diff spinning good and free. It feels great. And again, we're going to check to see if we have any end float, which we do not. There we go. Center diff is installed and all set up. All right, now that we have the center diff all set up and we have our races set and we got our preload set, now we can take the front output housing off one more time, get this thing reassembled, and we can put all this back together.